All right, we are at week 29 notes and video. This is the Pythagorean Theorem continued. So what we're going to do is start with a little review. So we're going to calculate the area of the following figures. So number one is a rectangle. That's for 90-degree angles. To find the area of a rectangle, we multiply length times width. So 6 times 4. 6 times 4 is 24, and we don't have a unit, so we're just going to put units squared. The second one is a square, 4 congruent sides and 4 90-degree angles. If one side is 5, that means they are all 5. And again, we're going to calculate it by multiplying length times width, or side times side. So that one is 5 times 5, which is 25 units squared. Next one is a triangle. The area formula for a triangle is base times height, and then we divide it by 2. So for this one, we're going to multiply 4 times 5 and divide it by 2. 4 times 5 is 20. 20 divided by 2 is 10 units squared. Number 4 is also a triangle. Our base is 8, and our height is 6. So we're going to multiply 8 times 6 and then divide by 2, which is 48 divided by 2, which is 24 units squared. And the last one again is a triangle, so we're going to multiply base times height and divide it by 2. So we get 3 times 4 divided by 2, which equals 12 divided by 2. 12 divided by 2 is 6 units squared. The second section is we're going to identify and name the following sides of the triangles with either leg or hypotenuse. Also identify and note the right angle. So let's do the right angle first. This is our right angle, 90 degrees, and we can tell it's a 90-degree or right angle because of this little box. Okay, so those are our right angles. Okay, now we're going to do leg. So the legs are the two sides that make up the right angle. So on number 6, that would be a leg, and that would be a leg. So we're just going to write leg and leg. For number 7, again, we find our right angle, and we do our two sides that make up the right angle, and we label them leg and leg. Number 8, the two sides that make up the right angle are on top, leg and leg. And number 9, top and the right-hand side are the two sides that make up the right angle, so those are the legs. What's left is called the hypotenuse. It is the side opposite the right angle. It does not make up the 90-degree or right angle. So hypotenuse Hypotenuse. Hypotenuse. A smaller pen here. Hypotenuse. Number 8, Hypotenuse. And number 9, Hypotenuse. Okay, so we've identified the legs, the hypotenuse, and the 90-degree angles in our right triangles. Moving on, side classification and angle classification for triangles. So we're going to classify the following triangles. The first is by side. So we have isosceles, scalene, and equilateral. So the first one is 3 congruent sides. That is our equilateral. E-Q-U-I-L-A-T-E-R-A-L, equilateral. Number 11 says at least 2 congruent sides. Typically it is exactly 2 congruent sides. Otherwise it would be an equilateral. And that one is our scalene, or sorry, isosceles. I-S-O-S-C-E-L-E-S. And the last one has no congruent sides. So all 3 sides are different lengths. And that is the scalene. S-C-A-L-E-N-E. You can tell by looking at the picture because they have matching marks. So those all 3 have the same line, so those are congruent or equal. Number 11 are isosceles. We have 2 sides that have matching marks, so those 2 are congruent or equal. And the last one has no matching marks, or you might see something like this, where they're all different, and that tells you that they are not the same. So that would be a scalene. The last one on this page is we're going to do classification by angle. And our options for that are you could have a right triangle, an acute triangle, an obtuse triangle, or equiangular triangle. So the first one says it has 3 acute angles. 3 acute angles, or 3 angles less than 90 degrees. That's going to be our acute triangle. All 3 angles are acute. Number 14, again, we are looking at our matching mark, so we can tell that all 3 of those angles are congruent or the same. So that would be our equiangular. E-Q-U-I-A-N-G-U-L-A-R. It's not equal angular, it's equiangular. Okay, number 15 says it has 1 right angle. Those are the ones we've been focusing on. That is our right triangle. Can only have 1 right angle in a triangle. And then the last one is it has 1 obtuse angle, so that's more than 90 degrees. And that would be an obtuse triangle. And you can tell this angle right here is more than 90. 90 would be straight up and down, and this one you can tell goes a little bit farther to the right there. So that's more than 90, so that's obtuse. All right, moving on. Go ahead and turn the page. Okay, so this is the Pythagorean theorem. It is a squared plus b squared equals c squared. We know that a and b are always going to be our legs. Okay, our 2 legs. It does not matter which one you make a or which one you make b, you'll get the same answer. A and b are always the legs, and c is always your hypotenuse. Okay, and we also know that the hypotenuse is always the longest side. So if you don't have a picture, if you just have the side lengths, you can tell which one the hypotenuse is because it is the longest, always. The longest side. So the Pythagorean theorem states that in a blank triangle, what type of triangle? A right triangle. The sum of the blank of the legs is equal to the blank of the blank. So what do we do with the legs? Well, we square them. So the sum of the square of the legs is equal to the square of the hypotenuse. In a right triangle, the sum of the square of the legs, so that's a squared plus b squared, is equal to the square of the hypotenuse. And that is your c squared. Number 19, it says we're going to explain the proof of the Pythagorean theorem. So we'll talk a little bit about that, and then you guys are going to do number 20. So it says if you have a right triangle and you square the hypotenuse, it will be equal to the sum, add, of the squares of the two legs. Okay, basically, we just rewrote what we had in number 18. Just said it a little bit differently. So let's look over here at the picture. We have a right triangle. Here is our right triangle. We have our legs, A and B, and we also have our hypotenuse, C. If you square the hypotenuse, so C squared, what is C? 1, 2, 3, 4, 5. If you square it, which would be 5 times 5, okay. It's a visual representation of 5 times 5. So if you square that, it's going to be equal to the legs squared and added together. So our A is a 4 by 4. Here's a visual representation of 4 squared. And our other leg, B, is 3. Here is a visual representation of 3 squared. So you can count the squares to figure out what that equals, or you can just multiply A squared, or B squared, or C squared. So what you're going to do is you're going to explain this example on the right. Count up the squares. Follow your formula. And come up with an explanation as to what we are looking at right here. Okay, just a sentence or two. Please make sure you do it for full points. If you need help, just ask us. The bottom part of this page is actually solving for a missing side. Sometimes it's a leg, sometimes it's the hypotenuse. So the missing sides are labeled. Let's start with number 21. The two sides that make up our right angle are always going to be your legs. So for our formula, we're going to do A squared plus 4 squared is equal to our hypotenuse squared, which is given to us this time. It is 5. So our equation is going to be equals 5 squared. When we solve, you always have to square your numbers first. Exponents come first in the order of operations. So 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. And we still have our unknown leg, A squared. When you're solving for a leg, you're going to need to do subtraction. So we're going to subtract to get rid of that. So we can isolate our A squared. So we get A squared is equal to 25 minus 16, which is, good, 9. I know you said it. Our last step is always to take the square root of both sides to cancel out our squared. So when you do that, you've canceled out r squared. So we just have A right there. And now this tells us that our answer, A, is equal to the square root of 9. Since 9 is a perfect square, we know that 3 times 3 is 9, so that is your answer. A equals 3. And that's 21. We could put a 3 right there if we'd like. For 22, we're going to do it the same way, but this time both of our legs are known numbers, the two that make up the right angle. So we have 5 squared plus 12 squared is going to be equal to our hypotenuse, which we don't know, so we're going to put the c. Don't forget the squared. Okay, when we solve, do your exponents first. So we're going to do 5 squared. 5 times 5 is 25. 12 squared. 12 times 12 is 144. And that is equal to c squared. When we're solving for the hypotenuse, we don't need to subtract. We just need to add. So we're going to do 144 plus 25. 5 plus 4 is 9. 4 plus 2 is 6. And 1 plus nothing is 1. So we get 169 is equal to c squared. And just like before, our last step is always to take the square root of both sides to cancel out our exponent of 2. So over here, we have canceled out our exponent of 2. So we have c. And on the left-hand side, we know that our answer, or c, is equal to the square root of 169, which is 13. So our answer is 13. C equals 13. Okay, number 23. The two sides that make up our 90-degree angle are our legs, which are b and 6. So we have 6 squared plus b squared equals our hypotenuse of 10 squared. Multiply with your exponents first. So we have 6 squared, which is 36, plus our unknown leg b squared is equal to 10 squared, which is 100. Since we're solving for a leg, we do need to subtract to get b by itself. 36 minus 36 is 0. So we've canceled that out. So we have to subtract 36 from 100. So we end up with b squared equals 36 subtracted from 100 gives you 44. Oops, that's not right. 64. So now our last step is to take the square root of both sides to cancel out our squared. So we have b equals the square root of 64. Square root of 64 is 8. So b is equal to 8. And the last one, our two legs are 9 and 12. So we have 9 squared plus 12 squared equals our hypotenuse, c squared. Solve your exponents first. 9 times 9 is 81. 12 times 12 is 144. And that equals c squared. We're going to add these together. So we're going to add 1 plus 4 for our 1s, which is 5. And we're going to add 4 plus 8, which is 12. Carry the 1. And we're going to add 1 plus 1, which is 2. So we get 225 is equal to c squared. Our last step to cancel out the squared, our exponent, is to take the square root of both sides. That cancels out your squared, your exponent. So we have equals c on the right-hand side. And the square root of 225 is 15. So c equals 15. Okay, go ahead and turn the page. Right triangles can relate to those. So here are two figures. First is a pyramid. The second is a rectangular prism or a box. So if you look at diagram number 1, we have a pyramid. And dropped straight down from the apex of our pyramid is a line. So picture that line and the very bottom of our pyramid. Those are going to make a 90-degree angle. The bottom of our pyramid is a square, and we drew a line straight up from the center to the top of our pyramid. So this right here is a 90-degree angle. Okay, so I'm going to draw that over here. I'm going to draw it two-dimensional so it's a little bit easier to see. So from the base of our pyramid, the bottom of our pyramid, that's the center, we have a line drawn straight out to one of the vertices. And again, that's made up of, that makes a 90-degree angle with our blue line that went straight up. So we have, I'm going to draw that one as well. Those two actually are making up the legs of our right triangle. And the last piece of our triangle is the connection from the top of the pyramid over here to point A. That is our hypotenuse. So you can see there is actually a right triangle inside that pyramid. Sometimes it can be a little tricky to see because it is a two-dimensional right triangle inside a three-dimensional pyramid. And we do have some measurements from our picture. We know that our blue line is 12. And we also know that our red line is 5. So with those two pieces of information, we can use the Pythagorean Theorem to figure out what C, our hypotenuse, is. 5 squared plus 12 squared equals C squared. Okay, so if you look at some of the questions on here, it says, how would you find the length of segment AV? AV is that hypotenuse. So we use the given dimensions, we make a right triangle, and we solve for C, our hypotenuse. Do you see a right triangle inside the shape? I tried to help you see that, so hopefully you do. Okay, and then looking on to our second diagram, our rectangular prism or our box. Do you see a right triangle there? And how would you find the length of segment AF? So we're looking for AF. Is that a leg or the hypotenuse? Do you see the right triangle in the shape? So explain what pieces of information you would need to know in order to solve for that green line, AF. What do you need to do? What would you need me to give you in order to figure out what the length of line segment AF is? And that's what you're going to do right here. Question number 25, you're going to explain how you would find the length of segment AF in the diagram on the left. There are no numbers, so just use the line segment names. Like the green one is AF. Okay, so go ahead, you can pause the video while you're doing that, and I'll meet you down at question number 26. So question number 26 says, use the following rectangular prism, that's a box, and construct the right triangle that is shown in the video. Follow along as we calculate the sides of the right triangle. So you guys are going to need to copy this down. We're going to make a right triangle. All right, we are going to construct our right triangle. So the first line I want you to draw is UW. So from U to W. Okay, the second line I want you to draw is UQ. UQ. And the last line, the third line, is QW. Q all the way down to W. Okay, that is our right triangle. And again, just like before, we have a line that goes straight up and down to the base of our rectangular prism or box. And then we have a line that goes from one side to the other side. So that right there is your 90-degree angle. That doesn't look like a good box. Go like that. Okay, that is our 90-degree angle. So let's draw that triangle. Okay, so that's Q on the top, U on the bottom, W down here on the right, and our hypotenuse. Okay, do we know any information? What do we know so far? Grab our highlighter. And we know that the height of our box is 12. So which line represents the height or how tall this box is? Well, that's going to be from U to Q. Goes from the bottom left-hand corner of our box to the top left-hand corner of our box. So that is the height. So that one is 12. So let's label that as 12. Okay, do we know anything else? We have something here on the bottom. Let's get a highlighter. We have this. Okay, if I were to be able to calculate UW, this one right here, that would help me. So I see I have a triangle, and again I notice that I have a 90-degree angle in it. Can you tell where the 90-degree angle is? Remember, it's a three-dimensional figure, so it's kind of hard to tell. The 90-degree angle is right here. It doesn't look like 90-degree angle, but it's the corner of a box. Corner of a box is a 90-degree angle. So let's draw that triangle. We have our 90-degree angle, which are 3. We can see our measurements, 3 and 4. Oops, I'll make the taller one 4. 4 and 3, doesn't matter. And then we have our hypotenuse, which is the one that I need. I need UW. So that's UW right there. So can I use the Pythagorean theorem to solve for this red line? I sure can. So our legs are 4 and 3. So 4 squared plus 3 squared equals my hypotenuse, c squared. 4 squared is 16. 3 squared is 9. And that is equal to c squared. 16 plus 9 is 25. That's equal to c squared. So I know right away, once I take the square root of both sides, I'm going to get 5. Square root of 25 is 5. So c equals 5. So this one right here is 5, which means this one right here is 5. My red line right there, UW. Okay, so I can add that to my drawing over here. UW is 5. So now I have a right triangle with 2 legs and an unknown hypotenuse. I can again use the Pythagorean theorem to figure out what QW is, or C. So we have 5 and 12 are our legs. 5 squared plus 12 squared equals our hypotenuse, c squared. 5 squared is 25 plus 12 squared, 144, is equal to c squared. We're solving for a hypotenuse, so we just add 144 plus 25 is 169. So that's what c squared is equal to. And my last step is to take the square root of both sides. So I get the square root of 169 is what c is, and that is 13. Okay, so I just solved for QW. This one right here. This one right here, my two-dimensional version. And we know that QW is 13. Okay, so the last one on this page is number 27. I'm going to give you the numbers and you are going to solve. All right, so we are on 27. We're going to find the length of AF, which on the top of this page it asked you to explain how to do that. So this is what we're going to do. If you'll notice, we do have a right triangle right here. Triangle ABC is a right triangle. And we know that because we have a right angle right here. Angle B is a right angle. It's a 90-degree angle because it is the bottom corner of our box. So I'm going to redraw that triangle for you. Okay, and angle B is our right angle. Straight up we have A, and over here on the side is C. So let's fill in what we know. Well, I haven't given you any numbers yet, so let's do that. This one right here is smaller pen. CB is going to be 9. And this is 8. Okay, so this one right here is 8. So we also know that this is 8, this is 8, and that is 8, because it's how tall our box is. So that was 8, and we know that CB is 9, so let's add that. And I'm going to give you AB also, which is 12. Let's get a different color. Okay, so this is 12, AB, so that means that AB right here on our diagram is 12. And these are all also 12. Okay, all the purple ones are 12. So we have our right triangle here, our diagram. So let's find what our hypotenuse is, C. We have A squared, or 9, plus B squared, which is 12. That's going to equal our hypotenuse, C squared. Okay, so 9 squared is 81. 12 squared is 144. And we know that that equals, when you add them together, C squared. So we're going to add 81 plus 144, and that's going to give us 225 is equal to C squared. And just like before, we're going to take the square root of both sides to cancel out our exponent of 2. So that's going to leave us on the right with just C, and the square root of 225 is 15. Okay, so we found AC, which is 15. Let's get a more pink. There we go. All right, so that is AC, which is 15. So this guy right here is 15. Okay, so that is enough information to find our AF length. And let me highlight this triangle in here for you so you can see it a little better. Do it in blue. So this is the triangle that we're using, and it is a right angle. Oops. There you go. So we have AF, which we don't know, that's what we need to find. We have AC, which we know we just found, that's 15. And then we have CF, which is our green one, which we know is also 8. Okay, so let's redraw our triangle. The right triangle. AC. And then we have F over here. And let's fill in with what we know. We know that AC is 15. Get my pink bag. Okay, AC is 15, it's this one right here. And we also know CF, which is 8. And the last one is AF, which is what we need to find. So we have 15 and 8 are our legs. So we'll do 15 squared plus 8 squared. And that will equal our hypotenuse, c squared. Okay, so 15 squared is what we're going to do first. 15 times 15 we already know. From right here it's 225. And then plus 8 squared, which is 64. And we're going to add those together and it equals c squared. 225 plus 64 is 289. So that's what equals c squared. Take the square root of both sides to cancel out our exponent of 2. So we have equals c. And our answer is the square root of 289, which is 17. 17 units. That's our answer. Okay, turn the page. Next thing we're going to talk about is a cool trick to help save you guys some time and effort. So these are called Pythagorean triples. And basically, you just want to memorize the combination of side lengths for your right triangles. So a Pythagorean triple is the 3 side lengths of a right triangle. And if you can become familiar with these numbers, then it will save you time. So we're going to list 8 of them, and then we're going to just use that information to fill in the sides for number 30. Okay, so the first one is probably the most common right triangle. It is a 3, 4, 5. And do you know which one the hypotenuse is? The hypotenuse is always the longest side. Okay, so the hypotenuse on that one would be a 5. We can do multiples of those numbers. So if we double 3, if we double 4, and if we double 5, that will also make a right triangle. So that one would be a 6, 8, 10. And do you know which one the hypotenuse is? It's the longest one. So 10. Okay, another common one is a 5, 12, 13. 7, 24, 25. 8, 15, 17. And here's another multiple. This is a 9, 12, 15. So that was a 3, 4, 5 multiplied by 3. So 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. Okay, another one is 10, 24, 26, which is actually a multiple of the 5, 12, 13. And the last one we're going to give you is 12, 16, 20. So the more of these that you can memorize, the less work you're going to have to do. And we know which one the hypotenuse is on all of these. Always the longest side. Okay, so these ones are actually, all the hypotenuses are the last number that I gave you. I like that one. Okay, so those are the hypotenuses. All right, so let's use this information and let's fill in our missing side lengths for number 30. So the first one is a 5, 12, blank. And we're looking for the hypotenuse because it's opposite the right angle. So let's look at our Pythagorean triples. And do you see any that have legs of 5 and 12? I do right here. It's a 5, 12, 13. So we know the hypotenuse is going to be 13. Okay, the next one, we have a hypotenuse of 10 and a leg of 6. Hypotenuse of 10 and a leg of 6, so we know our other leg has to be 8. So B equals 8 for the second one. For the third one, we have a hypotenuse of 26 and a leg of 24. So that would be this one, hypotenuse of 26, a leg of 24, so our other leg is going to be 10. So A equals 10. Okay, and then you guys are going to do this last one. It is a 5, 12 for our legs. Figure out what the hypotenuse is. All right, number 31 states that the converse of the Pythagorean theorem says that if you have a triangle and you square the shorter sides and add them together, it equals the square of the longest side, then it is a right triangle. So if you're given all of the numbers, we can determine if it's a right triangle or not. So if a squared plus b squared does equal c squared, then yes, it's a right triangle. So let's look at the first one. We have legs of 5 and 10. We know this has to be, the 15 has to be the hypotenuse because it's the longest number that's given to us. So let's square those and see what we get. So we have 5 squared plus 10 squared. We're going to see, does that equal 15 squared? So that's a question mark, we're not sure. Well, I know 5 plus 10 equals 15. So let's see if it works when you square them. Okay, 5 squared is 25. 10 squared is 100. Does that equal 15 squared, which is 225? Well, I can tell right away that 100 plus 25 is 125, and that does not equal 225. So this is not a right triangle. Okay, so we're not going to put the box in the corner. The second one, my hypotenuse is the longest side, so that's 5. And my legs are going to be 3 and 4. So we're going to see if 3 squared plus the other leg, 4 squared, does equal 5 squared. Those numbers look familiar. If you go up to the top, do you see a 3, 4, 5 in our Pythagorean triples? Yes, we do. So we do know this is a right triangle because we have 9 plus 16 does in fact equal 5 squared, which is 25. So this is a right triangle, so we're going to add our box in the corner. Okay, remember it's always opposite the hypotenuse. So yes, this is a right triangle. Okay, and the last one, the hypotenuse is the longest side, so 6. So we're going to see if our legs 4 squared plus 5 squared equals 6 squared. 4 squared is 16, 5 squared is 25, and 6 squared is, not 6, 36. Okay, question, we're not sure. 16 plus 25, does that equal 36? I don't think so. What is 16 plus 25? 41. 41 does not equal 36, so is this a right triangle? No, not a right triangle. Okay, so that's called the converse of the Pythagorean theorem, and you use the Pythagorean theorem to determine if a triangle is a right triangle. Just plug in the numbers and see if it's true. So the bottom is some questions for you guys to answer. So the first one, 32, what is the Pythagorean theorem? Just write the equation. On the next line, that you'll notice a star, dotted line. I'm going to tell you a joke, and I want you to write the punchline. Okay, it's hilarious. Are you ready? Why did Anakin Skywalker cross the road? Ready? Ready? Do you know? Do you know? To get to the dark side. Ha ha ha. That's a good one. All right, so you're going to write that on that line, dotted line. You're going to write to get to the dark side. Number 33. When do we use the Pythagorean theorem? What type of triangles do we use it for? And what does it help us find out? In the last one, number 34, you're going to write a sentence summarizing the Pythagorean triples and how it might be useful. We've already used it, and it's already been useful. So go ahead and write a sentence or two explaining how you might use the Pythagorean triples and why you think they're useful. All right, that is it. Make sure you complete all of the extra questions we didn't finish before you turn it in. You can always turn it in on Friday after you take your test.